Before we use the law of cosines in the case where you're given three sides, the SSS, I'd like you to pause the video and see what happens when the angle that you use is 90 degrees when using the law of cosine. So basically what I'd like you to do is just keep all the variables in here, the c squared, the a squared, the b squared, the a and the b, and just put in 90 degrees and see what happens. And when you're done simplifying that expression, start the video and we'll compare our answers. So I've got c squared equals a squared plus b squared minus 2ab cosine 90. And you remember that on a unit circle, if we're at 90 degrees, the ordered pair is 0, 1. So the cosine is the x-coordinate on a unit circle, so the cosine of 90 degrees is equal to 0, leaving us, which is c squared equals a squared plus b squared, which is the Pythagorean theorem, and this also makes sense. This is true in what type of triangle? It's true when you have a right triangle, and so if you have a right triangle, there's no need to use the law of cosines. You certainly may, but it really is just going to come down to the Pythagorean theorem. Alright, so let's use the law of cosines to solve a side-side-side problem. So the first thing we're going to do, we've got three different sides, 6, 9, and 4, so we'll draw the triangle. And you'll notice that I have started putting my A in a different spot just to show you that it really doesn't matter. I get in the habit of just drawing my triangle the same exact way every time. But as long as if you label it A, B, C in some way, you just have to be consistent in that the side opposite angle A is side A, B is side B, and C is side C. We need to find an angle, and so we actually have to manipulate the formula for the law of cosine so that we can solve for the angle. But what's really important here is that when you're using the law of cosines for side, 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 is that you want to find the largest angle first. This way, if there is an obtuse angle, you'll have found it, and when you go to use the law of sines, you won't run into the ambiguous case. If there is an obtuse, we'll get that out of the way. So I'm first going to write down the law of cosines. And instead of typing all of my values in and then solving for cosine B, I'm actually going to solve for cosine B generically. So if I want to solve for cosine B, the first thing I have to do is subtract a squared and c squared from each side. So I get b squared minus a squared minus c squared equals negative 2ac cosine B. And then I'm going to divide each side by negative 2ac. This will cancel, and so to keep cosine B is equal to b squared minus a squared minus c squared divided by negative 2ac. If I multiply the numerator and the denominator by negative 1 just to eliminate some of those negative signs, what I end up with is that cosine B is actually equal to a squared plus c squared minus b squared all over 2ac. Now I'm going to use this formula. What I've done is I've actually retyped these below for you to use and refer to. You can see the cosine A, you're dividing by BC. Cosine B, you're dividing by AC. Cosine C, you're dividing by AB. And so the formulas are similar. Again, these you don't have to memorize because you can derive them, but you will be given on a test the original formula for law of cosines, and you can use that to derive this formula. So these won't be given to you on a test, but you have enough information to get these. So I'm going to erase this and actually use the formula to find B. We've got cosine B equals a squared plus c squared minus b squared over 2ac. So we'll fill in the values. So typing in the values here, I know that the cosine of B is equal to this expression. So let's enter this on our calculator. We want the inverse cosine. I need to open a set of parentheses for my numerator, which is 36 plus 16 minus 81. Close the parentheses on the numerator and then divide by the denominator. So I'm going to either evaluate the 2 times 6 times 4 in my head, which is in this case is pretty easy to do, 48, and then close the parentheses. If I choose to multiply this out on the calculator, I'm going to need parentheses around the 2 times the 6 times the 4. Another option is just to evaluate the numerator and the denominator separately, and so we do 36 plus 16 minus 81 for the numerator, hit enter, and then do the 2 times 6 times 4, which again, this you could do in your head. And so we know we want the inverse cosine of negative 29 over 48. So we'd have inverse cosine negative 29 over 48. In either case, you get 127 degrees. It really just becomes a choice for you how you use the calculator, what you're more comfortable with. But just remember, just never round until the end of a problem. So you wouldn't want to round this fraction and then take the inverse cosine of a rounded value. Alright, so now our next job, we've got one angle. We already have the obtuse angles, so we don't have to worry about running into the ambiguous case. So you can use the law of sines to find either of the remaining angles and then find the last angle by subtracting from 180. So we'll set this up. So after setting up our ratios, we have the sine of c is equal to 4 sine 127 over 9. We'll use our calculator to do second sine of 4 sine 127 divided by 9. And we get approximately 21 degrees. So from here, to find the last angle, we just take the 180 minus the 21 minus the 127, which gives us 32 degrees for angle A. And again, you can use the law of sines to check your work. In the next video, we will look at some applications.